Welcome to Sailor Faison.
Today, we're tracking down the beating heart of a ship, the exact machine required to wake up its massive main engines. You know, if you've ever stood next to a modern cargo vessel or a cruise ship, you've probably wondered what it actually takes to kickstart machinery of that literal magnitude. I mean, it definitely doesn't just turn on with the flick of a little switch. It requires a tremendous concentrated force. So today, we're zooming in on the critical piece of heavy machinery that provides exactly that force, the Marine Air Compressor.
All right, here's our blueprint for today. We're going to cover the heart of the ship, the anatomy and drive components, the two-stage compression journey, safety and monitoring instruments, and finally, a step-by-step operational procedure.
Let's jump right into Section 1, the heart of the ship and how it powers the beast.
Now, this part is actually super fascinating. There's this very clear separation between the intense 30-bar pressure required for engine starting and the much lower 7-bar pressure used for general ship services. Think about that for a second. 30 bar is incredibly dense. That is the raw, explosive push you need to crank those massive main and auxiliary engines. But a ship doesn't just need brute force, right? It needs finesse. So that exact same compressed air gets stepped down to 7 bar to safely run the ship's delicate control systems and general services without literally blowing them apart. It's one single machine providing both the heavy muscle and the fine motor control for the entire vessel.
Moving right along to Section 2, anatomy and drive components, basically the bones of the machine. Okay, so the standard configuration we're looking at today is the highly durable reciprocating tandem type compressor. Reciprocating just means it uses pistons driven by a crankshaft to compress the air, moving back and forth. And tandem points to its specific multi-stage cylinder arrangement that works in perfect sequence. This design is the absolute go-to because it's incredibly robust, super reliable, and more than capable of continuously generating that extreme 30-bar pressure we were just talking about.
It's literally a brilliant chain of kinetic energy. The electric motor is the primary muscle, wired straight into the ship's electric panel. It connects via flexible coupling to spin the flywheel and the crankshaft. Then, the main bearings support this huge spinning shaft, while the connecting rod catches that rotational motion and violently translates it into punishing up and down piston strokes. And obviously, because all this metal-on-metal friction generates massive amounts of heat and wear, engineers rely on a surprisingly simple but totally vital crankcase sight glass to visually verify the lubricating oil level.
Take a look at the sheer scale of the forged components here. We are dealing with a massive one-piece crankshaft. And you see those counterweights? Yeah, those aren't just for show. They're absolutely crucial for dynamic balancing during high-speed rotation. Without them, the extreme twisting forces would just violently snap the metal. No way it would survive. Also, the crank pin and journal pin are highly polished to ensure the big end and main bearings have a really long working life. And speaking of those bearings, they're crafted from a super tough copper-lead alloy to give ultimate rigidity to the entire rotating mechanism.
All right, Section 3, the two-stage compression journey. Taking a breath of air.
Okay, this is where the magic, and honestly the violence, really happens. That spinning crankshaft connects to a forged alloy steel connecting rod, which is designed to minimize the thrust pushed onto the bearing surfaces. This rod transfers all that massive power straight up to the alloy steel piston rod. Then, the piston rod physically shoves the piston upward, violently trapping and crushing the air. And finally, we get the streamlined discharge of that highly pressurized air. It is a crazy violent, yet mathematically precise sequence of events.
Let's actually follow a single breath of air through this thing. It all starts at the air filter, pulling in ambient room air. It rushes through the first stage suction valve, gets violently compressed, and gets pushed out the discharge valve. But squeezing air makes it dangerously hot, so it has to run through an intercooler before it hits the second stage. Then, it enters the second stage suction valve for an even tighter, much more intense compression. Finally, it passes through an aftercooler, and crucially, into a moisture and oil separator. Because let's be real, you absolutely cannot have wet, oily air shooting into your starting engines. That final separation step is just vital for the ship's health.
Now, before we go any further, we really need to highlight the unloader valve. Think of it this way. Trying to start an electric motor against an already fully pressurized system is kind of like trying to pedal a bicycle uphill in the highest gear from a dead stop. You'd burn the motor out almost instantly. The unloader valve brilliantly solves this. It stays open during startup, discharging air from the first and second stage separator pots. This keeps the load on the motor nice and low until it's comfortably up to speed. It's a total game changer.
Next up is Section 4, Safety and Monitoring Instruments, or, as I like to think of it, the machine's nervous system.
With all that intense pressure building up, you need a strict array of trips and switches, constantly watching 3 vital signs: air, water, and lube oil. If the discharge air gets too hot or overpressurizes, a dedicated high-temp switch or a second-stage relief valve jumps right into action. On the water side, which, remember, cools the whole operation, the flow is watched super closely, and a bursting disc sits ready just in case of overpressurization. And finally, the lube oil system is heavily guarded by a low-pressure switch. If oil pressure drops, or if that discharge temp spikes, bam! These safety trips instantly kill the compressor to save the machine. So, once the air survives that whole journey, it gets stored in these heavily fortified air receivers. And I mean fortified. These aren't just empty steel cans. They're essentially vaults equipped with an inlet valve to let the air in, a massive manhole door for physical maintenance access, a pressure gauge, and their own independent safety valves. Plus, because compressed air inevitably drops out condensation, they feature both manual and automatic drain valves to clear out pooled water. You've got to keep that 30-bar air absolutely pristine until the ship needs it.
Okay, Section 5, the step-by-step operational procedure. It's time to fire it up.
Look, you can't just walk up and smash a green button to wake this beast up. It requires a really precise pre-start sequence of systematically opening specific water, discharge, and receiver valves. First, you establish your cooling flow by opening the cooling water inlet and outlet valves. If you skip this, the machine would literally tear itself apart from the heat. Next, you clear the path for the air by opening the valve on the compressor's discharge side. And finally, you open the air inlet valve to the receiver. The cooling is active, the path is set, the machine is ready.
So you flip the power on, select auto mode, and instantly verify that the lubricating oil pressure gauge reads normal. While you're doing that, the unloader valve takes center stage. It stays open, discharging air from those separator pots to completely remove the initial load and protect the motor. Once the motor has safely spooled up to full speed, the unloader valve firmly closes. Right at that exact moment, if you're watching the panel, you'll see the amperage jump, the first and second stage pressure gauges climb, and the real pressure starts building up rapidly inside the receiver.
Now, as this compressor runs continuously, it sort of breathes. At fixed intervals, that unloader valve pops open for just a quick second to spit out the accumulated moisture and oil from the separator pots. When it does that, you'll actually see the first and second stage pressure gauges momentarily dip down and then smoothly rise back up as the valve closes. This whole dynamic process continues until the exact high-pressure set limit is reached in the receiver. Then the system automatically stops, and the unloader valve opens one last time to safely depressurize the internals. When you compress air like this, it gets insanely hot. And if you just leave that unchecked, the heat will completely ruin the machine's efficiency and damage the internal parts. Enter the intercoolers. These are often copper tubes fitted directly between the compression stages. Whether they're built right into the machine or attached on the outside, their whole job is to instantly cool down the air temperature before it hits the next stage of compression. Cooler air is denser air, and that cooling action is exactly what maximizes the volumetric efficiency of the whole system.
Meanwhile, hidden behind that iron casing, the rest of the life support systems are putting on a complex symphony. We've got water jackets wrapping right around the cylinder liners to draw away the intense heat of compression. There's a chain or gear-driven water pump circulating that coolant, and at the exact same time, a dedicated lube oil pump, which has its own regulating screw and inlet filter, guarantees a particle-free flow of oil. This oil coats those heavily stressed copper-lead bearings we talked about earlier, absorbing heat and stopping metal-on-metal friction. It's basically this intricate dance of fluids keeping the whole beast alive.
So the next time you see one of those colossal cargo ships cutting across the ocean, ask yourself, could that Titan have ever left the dock without this single, perfectly synchronized machine squeezing the breath of life into its hull? It is literally the heartbeat of global shipping. Keep asking questions, and I'll catch you on the next explainer.
Thank you for watching. Please like, comment, share, and save the video. Do not forget to subscribe to my channel.